Hello everyone, and here we are with lesson 5.3 on quadratic functions. This is a bit of a long lesson. There are 5 pages of notes, although it's not all writing. There's a lot of graphs and things in it. And then the next lesson, 5.4, is really short. You'll like it. It's only 2 pages, okay? And then that's it. That's it for the course for this year, okay? All right. So we have so far, we've looked at the general form of the equation of a quadratic function, which is f of x equals ax squared plus bx plus c. So that's this first one up here, where a, b, and c are real numbers, and a is not equal to 0. We looked at the and what we learned from the general form is that the a tells us whether the parabola opens up or down, how flat or shallow is it, and we learned that c is the y-intercept of the equation. Then we looked at the vertex or standard form, where it's the second one, where f of x equals a times x minus h all squared plus k, and hk is the vertex of the parabola. A is actually the same value as a in the first equation, where a is, does the parabola open up or down, and how tall or shallow is it? And today we're going to look at a third form of the equation, which is called the factored form, and it comes in the form of f of x equals a times bracket x minus m times x minus n, or of course y equals the same thing. And our only requirement here is that a is not equal to 0, and that a is in fact the same value as it is in the other two equations. And just as the general and vertex forms provide us with specific information about the function, the factored form does as well. Different information though. So we're going to use technology, i.e. Desmos, to graph the function. So there's the graph of the function, and we're going to sketch it. So the important points that we want to show on our graph are the y-intercept at 0, 24. Remember that the x-axis and the y-axis don't have to have the same scale, but it should make sense, so that if this is where I'm going to put my 4 for one of my y-intercepts, or my x-intercepts right here at 4, 0, then this is 2, this is 3. So there's my intercepts at, this one is at 3, 0. This one is at 4, 0. And then I also have my my vertex, which is at 3.5, negative 0.5. So it's really, really close to here. And then I'm going to draw my parabola through here. And it's just a sketch. It doesn't have to be fantastic, but it should hit those points. And then I've got a dot there, and I'm going to write that this is 3.5 minus 0.5. I think it's time to get a new pen. This one is not working very well. Okay, so what are the x-intercepts for this graph? Well, the x-intercepts are 3 and 4, and the y-intercept is 24. And I want you to notice that those numbers, those 3 and 4, are right there in the equation. And the x-intercept of 24 actually equals 2 times 3 times 4. So that information is right there as well. And the axis of symmetry on our graph is at x equals 3.5. Remember, it's an equation. You have to have that x equals there. And we can get that by doing 3 plus 4 divided by 2, right? It's always going to be between the two x-intercepts, like in the middle between the two x-intercepts. All right. I invite you to pause and do the second example and then come back and check it. I'm just going to keep going. So this one is going to be negative 2x plus 1, x minus 3. Okay, and let's move the graph a little bit. Okay, so when I graph this one, my y-intercept is going to be 6. So this is 0, 6. And it goes through negative 1, 0, and 3, 0. And the vertex is at 1, 8. So about there. Okay, so I'm just going to draw a nice smooth curve through all of those points. Put some arrows on the end, which I forgot to do up above. Okay, so the x-intercepts are negative 1 and 3. Oops, forgot my brackets here too. The y-intercept is 6, so it's negative 2 times negative 1 times 3, which is 6. And the equation of the axis of symmetry, I'm going to take my two intercepts, negative 1 plus 3, divide that by 2. That equals 2 divided by 2 equals 1. So the equation for the axis of symmetry is x equals 1. Again, I will tell you, remember it's an equation, so it's x equals something. Okay? Okay, next page. So to summarize the features of this formula, the x-intercepts are m and n in the equation. The y-intercept is a times m times n. The equation of the axis of symmetry is x equals m plus n divided by 2. It's the average. If a is positive, the graph opens up and has a minimum point. If a is negative, the graph opens down and has a maximum point, just exactly like we saw before. All right. Okay. Example 2. Without graphing, state the x-intercepts, the y-intercept, the equation of the axis of symmetry, and the direction of the opening of the graphs. Okay, so here's my tip. Rewrite the equation like this first. This is not exactly like that, is it? So let's rewrite it. So whether we use y or f of x doesn't really matter. So we can do f of x equals, what's my a value here? Well, it's 1, right? So let's put that there. And then I want to write this as x minus something because that's the form that I'm using. Actually, here, what I usually do is do this in 2 colors. And I do it like this. And I'll do like an underline there and an underline there. Oops. It's going for the eraser there and an underline here. And then I'm going to fill in the numbers. Okay. So my a is 1. This needs to be, in order for this x minus something to equal x plus 4, this needs to be x minus negative 4, and this one is x minus 10. So, oops, just fix that 4. All right, so the x-intercepts are my m and my n, so it's negative 4 and 10. My y-intercept is 1 times negative 4 times 10, which is negative 40. My a equals 1, therefore it opens up. And the axis of symmetry, symmetry is x equals negative 4 plus 10 divided by 2, which is 6 over 2, x equals 3. Okay? Make sure you don't circle this as the answer because 6 over 2 is not the answer, 3 is not the answer, x equals 3 is the answer. All right? Okay, I invite you to pause and try these next couple on your own and then check your answers. I'm, again, just going to keep working. So g of x equals something times x minus something times x minus something. So that's going to be -2 times x minus -6 times x minus -9. So my x-intercepts are -6 and -9. My y-intercept is -2 times -6 times -9, which equals -108. A equals -2, therefore it opens down. And my axis of symmetry is x equals -6 plus -9 divided by 2, which is -15 over 2. And when we're graphing, it's okay to go to a decimal. So -7.5, because 7.5, because that's what you're going to try and graph if you do that. All right, one more. H of x equals oops, sorry, let's not get ahead of ourselves here. It equals, I need my a times x minus something times x minus something. So my a value here is -1, because there's an invisible 1 there, of course. And then this x becomes x minus something, so that's x minus 0, and this is x minus 20, that one's right there. So our x-intercepts are 0 and 20. The y-intercept is -1 times 0 times 20, which equals 0. Since a equals -1, therefore it opens down. And our axis of symmetry is x equals 0 plus 20 divided by 2, so x equals 10. And just for fun, let's graph that one. So y equals -x times x minus 20. All right, we have our x-intercept right here is 0, and that's also one of the y-intercepts. There's our other x-intercept at 20. The intercept, and it opens down, right? We don't find a vertex. This version doesn't give us the vertex, but it does give us those, the axis of symmetry, right? Which would be, it's going to go through 10. It's going to be x equals 10. Oops, x equals 10. There we go. I like to do that with a dotted line. There we go. Okay, so that worked. All right. Okay, this is the tricky bit, okay? Let's look at these two graphs in Desmos. Okay, so we have two different equations, and they are right on top of each other. And what we're asked to do, what do we notice about the two graphs? They appear to be the same function, appear to be the same graph. So how does the graph of y2 equals -2 times 3 minus x times x minus 7 open up when the a value looks like it's negative? Well, the trick here is that it's not written in the form that we've been using. So I'm going to write that down. It is not written in the form y equals a times x minus m times x minus n, because 3 minus x is not the same thing as x minus 3. So to fix this, okay, just watch, don't write this down yet, okay? So what we have is y equals -2 times 3 minus x times x minus 7. All right, I'm going to stick in here a couple of negative ones. So I'm going to change this to, I'm going to multiply this -2 times -1 times -1 times 3 minus x times x minus 7. Okay, now we're in agreement that -1 times -1 equals 1. So I haven't changed what the equation equals. It just looks different now. Okay, so now I'm going to group things. I'm going to group those together. And -2 times -1 equals 2. And I'm going to group these two things together. And I'm going to come over here. If I have -1 times 3 minus x, and I take my my distribution, my rainbow lines, my water bombing, whatever you want to call it, and I multiply that and that, I have -1 times 3, and I have -1 times -x, which equals -3 plus positive x, which equals x minus 3. So I'm changing this -1 times 3 minus x, and it becomes x minus 3. And then the x minus 7, I don't need to do anything to, it just stays as x minus 7. Okay, so now I have it in the form y equals a times x minus m times x minus n. Okay, but I had to plug in this -1 times -1 to be able to do that. So let's do a couple of examples of that. Okay, so I notice that I have a 1 minus x instead of an x minus 1, so I need to change the equation here. So this is going to be y equals -1 times -1 times 1 minus x times x minus 10. And remember, I haven't changed this equation's value, I've just changed what it looks like, because -1 times -1 is just 1, okay? Okay, so the -1 is going to stay there. This, I'm going to combine these two, that's why I put the -1 in. So -1 times 1 minus x becomes -1 plus x, which we write as x minus 1, and I'm going to put that back here, x minus 1. And this is minus 1, and this is x minus 10. So this is already in the correct form of y equals a times x minus m and x minus n, because we have minuses for both of those, so that makes this next part easy. The x-intercepts are 1 and 10. The y-intercept is -1 times 10, which is -10. Okay, and let's just graph that to make sure, okay? I completely encourage you to play with Desmos when you're doing your homework. I think it's so valuable to be able to see that things are what we want them to be. Okay, so our x-intercepts are 1 and 10, just like it's supposed to be, and our y-intercept, there we go, at -10. Awesome. Okay, let's do another example. And why don't you pause the video and try this one on your own. Although this one's tricky, you need to change both of them, because both of these equations have a negative, for a number minus the variable, minus x, instead of it being the other way around. So this time I'm going to write it as y equals -3 times -1 times 4 minus x times -1 times 12 minus x. So this time the only thing I'm doing different is I'm not writing my -1s right beside each other. I'm just spreading them out to where I need to use them. Okay, so my -3 is going to stay the same because my two -1s are being used up elsewhere in the equation. So this is going to change this to x minus 4, and this negative 1 is going to change this to x minus 12. All right, so we have our x-intercepts are 4 and 12, and our y-intercept is negative 3 times 4 times 12, which is negative 144. All right. Example 4. Each of the graphs on this page, and there are 4 of them, I just can't show them all at one time, has an equation in the form, sorry, that means it's not necessarily given in that form, but it has an equation of the form y equals a times x minus m times x minus n, where a, m, and n are integers. Match each equation with its corresponding graph. So the strategy here would be to take each of the equations and find the important points on the equation, that is the y-intercepts and the x-intercepts, and then see which, and opening up or down, and see which graph it matches. Okay, so this one I can write as y equals something times x minus something times x minus something. Okay, so let's fill in our somethings. This is 2, this is 1, this is negative 4. All right, so we know that it opens up because the a is greater than 0. And the x-intercepts are 1 and negative 4, and the y-intercept is 2 times 1 times negative 4, which is negative 8. Okay, so let's see if we can find a graph with x-intercepts of 1 and negative 4, and there are 2. So graphs C and D both have x-intercepts of 1 and negative 4. So there is a quiz for this unit, this section rather, which is going to ask you to do this, and you have to justify more than just, like, if you said that it's graph C because the x-intercepts are 1 and negative 4, your graph C might be right, but you haven't justified it enough because it could be graph D. You need to give me something else that says, no, it can only be graph D. And in this case, the y-intercept of negative 8 is the only one that works because the y-intercept of C is positive 8. So this has to be graph D, and just to check, it does open up. So this one is graph D. Put that here, so graph D, and then I'm going to just, for my own use, I'm going to write equation 1 with graph D so that I know that it's been used up. Okay, let's look at equation 2. So looking at equation 2, I noticed that, well, this is written wrong because it's 1 plus x, but that's okay. I can just switch places when it's adding, right? 1 plus x and x plus 1, those are the same thing. That's fine. This is the one that's a problem, so I'm going to need to use that negative 1 trick. So this is going to become y equals negative 1 times, and I'm going to write this as x plus 1 because it's the same thing. And then I'm going to put my minus 1 here times 4 minus x. So my y equals negative 1 times x plus 1 times x minus 4. And then I'm going to go one more step, and I'm going to write this out as my, with my my a, m, and n. So this is going to be x minus something and x minus something, which I'll do in red. So this is negative 1, this is negative 1, and this is just 4. So my x-intercepts are negative 1 and 4, and my y-intercept is negative 1 times negative 1 times 4, which is 4, and my a equals negative 1, so it opens down. So do I have one with an x-intercept of negative 1 and 4? So it's A or B, and it opens down. It should be graph B, and is my y-intercept 4? Yes. So this is graph B, and this is equation 2. Equation 3, I don't have I don't need the -1 thing, so I just can write this as y equals 1 times x minus -1 times x minus 4. So my x-intercepts are -1 and 4, and my y-intercept is 1 times -1 times 4, which is -4, and a equals 1, so it opens up. So which graph has x-intercepts of -1 and 4? I think I need to go up to the top, -1 and 4. My y-intercept is -1, and it opens up. Yep, so this is graph A, this is equation 3. And the last one, now, you could just skip it and assume that it's equation C, but I don't know. I could have done two graphs the same equation. We've seen that before, so we should work through this one as well. So this is going to be y equals -2 times x minus 1 times x minus -4. So my x-intercepts is 1, -4. My y-intercept is -2 times -1, oh sorry, times +1 times -4. I didn't do it in the different colors this time. It really helps, really, really, really helps to have those things written in different colors. Isn't that funny? All right, and my a equals -2, so that's going to open down. All right, so graph C, x-intercepts of 1 and -4, a y-intercept. Ooh, what did I do? Oh no, sorry, I didn't finish it. So that equals 8, right. So this equals 8 right there. Yeah, so this is equation 4. And this is C. Okay, one more question, one more page. And this is actually the harder part of it. Okay, this time you're given a graph and you're asked to actually find the equation of the graph from the graph that you're given. Okay, so the graph represents a quadratic function with equation y equals a times x minus m x minus n, and the x and y intercepts are shown on the graph. Here's the process. State the values of m and n. So we know that m and n are the x-intercepts. So m equals 3 and n equals 4. All right, find the value of a. Well, we know that the y-intercept equals a times m times n. And we know that the y-intercept is 24, so we can plug all those numbers in. So this is 24 equals a times 3 times 4. So 24 equals 12a. Divide that side by 12, divide that side by 12. We get a equals 2. Does that make sense? It opens up. Good enough. Meets the one criteria that we can do really quickly. Write the equation of the graph in the factored form. So this is going to be y equals 2 times x minus 3 times x minus 4. Or y equals 2 times x minus 4 times x minus 3. That's fine as well. Okay, let's find the coordinates of the vertex. Now I know that the vertex is on the axis of symmetry, and I know that the axis of symmetry is halfway between my two x-intercepts, or just to remember, between any 2 points that are on the same horizontal line. So if I knew this point and this point, the axis of symmetry is right in between. So x equals m plus n divided by 2. It equals 3 plus 4 divided by 2, which is 3.5. So I know that that is the x value of my vertex. I just need to find the y value of my vertex. And the y value of the vertex, so I'm going to come back to this graphing thing that every point on a line is the place that satisfies the x and the y value together, satisfy the equation of that line. Okay, so that means that I can take my equation that I have, which is y equals 2 times x minus 3 times x minus 4, and I replace the x with 3.5. So this becomes y equals 2 times 3.5 minus 3 times 3.5 minus 4, sorry, minus 4, which is 2 times 0.5 times negative 0.5, which is negative 0.5. So that is my y value, okay? And that specifically is the y value that goes with this x value, so that's 0.5, negative 0.5, okay? I hope that made sense, because that you're going to need to do a lot, okay? And then write the equation of the graph in standard form. So this is, so now to do that, in Foundations of Math 11, we don't learn how to do this algebraically. It's quite tricky to do it algebraically, but we do know that the vertex, we know with the vertex now, so we can just plug the vertex into here, okay? So this is going to be y equals a, and we know that a is 2, and it conveniently stays the same through all the forms of the equation. So it's 2 times x minus something all squared plus something. All right, and the minus something is the x value of the vertex, which is 3.5. And then it's plus the y value, which is negative 0.5. All right, and we would normally rewrite that as y equals 2 times x minus 3.5 all squared minus 0.5. Okay, but I will accept this one because I would rather you wrote it this way, because you're more likely to get the signs correct if you write it this way than if you try to write it this way. Write it, especially with the x one, because it's a negative, so you have to change it. But either of those is okay. All right. Okay, example 6. Determine the coordinates of the vertex of the graph and a quadratic function, or of a quadratic function, if the graph passes through points -8, 0, 2, 0, and 0, 48. So these are not random points. These two are the x-intercepts, and this one is the y-intercept. So that's exactly the information that we had for this graph up here. Well, other than we knew which way it opened, but we could sketch this really quickly and know which way it's got to do it. Got to do that. So let's do this. So we've got y equals a times x minus m times x minus n. So y equals a times, the x-intercepts are -8 and 0, so that's going to be x plus 8 and x minus 2, not 0. And then we know that the y-intercept equals a times m times n, so that means that 48 equals, don't need these equal signs here, 48 equals a times -8 times 2. So 48 equals -16a. If I divide that by -16, I divide that by -16, I get a equals -3. So my equation is y equals -3 times x plus 8 and x minus 2. Should we do a super quick sketch and see if our a is right? So our x-intercepts are -8 and 2, and the y-intercept is way up here somewhere, so it's definitely an opening down parabola, so a -3 is a good number for that. Okay, and we want to know the vertex. So the vertex has an x value. The x value of the vertex is the axis of symmetry, so it's going to be -8 plus 2 divided by 2, which is going to be -6 divided by 2, which is -3. And so our vertex, let's just find a place to write that. It's going to be -3 and something. And then what I want to do is take my -3 as my x value and plug that into my equation. So I've got y equals -3 times -3 minus 8 times -3 minus 2. And let's figure out what y is. It's going to be -3 times -11 times -5, which is 75. So that's the y value that goes with the x value of -3. Okay? I hope you saw that keeping your work organized and keeping track of what you're doing was really important for this section, because there are a lot of steps to go through to get your answer. One more thing I do want to show you before we go is this poster, which it's hanging in the classroom, but it's not particularly useful to you when you're at home. But if you want to either, I will post this picture for you online on Classroom, and if you want to print it out or do your own version of it, you are welcome to take this into the test with you, because I would have this on the wall in the classroom normally. So just to quickly go over this, when we look at the standard form, the A value here tells us that it's going to open up, and the C tells us where the y-intercept is, which is the -0, or sorry, 6, -6 right there. Okay, the factored form, and here's an example, gives us our y-intercepts, our x-intercepts of -1 and 3 right here. So those are right there. One of them is covered up. Sorry about that. And the vertex form gives us the vertex. It's right there in the equation, and there's the vertex. And then the axis of symmetry goes through the vertex. Okay. So that gives us the x value of the vertex. And then we can use the equation to calculate the y value of the vertex if we need to, as we did in those the last example. 3 equations, same graph. All 3 of these equations that I've got here, this equation here, and this equation here, and this equation here, are all this same graph. Okay, they're all, is that going to work for me? Can't see it. They're all this graph. Okay. All right, go do the homework. Make sure you ask for help on this if you're having troubles. This is, there's a lot of calculations in here. Okay, have a great day. Bye.